In this video, we talk about transport layer in TCP/IP model. First of all, we talk about the functions of transport layer. Then we list all the common protocols used in transport layer. After that, we'll discuss a real-world example. Then we perform the Wireshark analysis. Finally, we'll sum up the video with the keynotes. As you can see, transport layer sits between application layer and network layer. Therefore, transport layer responds to service requests from the application layer and issues service requests to the network layer. Transport layer defines protocols for setting up the level of transmission service for applications. Here are the major functionalities of transport layer. Create reliable end-to-end communication. Ensure the error-free delivery of data. Handles packet sequencing. Maintains data integrity. Transport layer identifies the protocols in application layer by the port number. For example, HTTP uses port 80. Telnet uses port 23. The two well-known protocols developed for the transport layer are TCP and UDP. TCP, Transmission Control Protocol, it is a reliable connection-oriented protocol. It requires handshaking to set up a virtual circuit between the two hosts. After the connection established, user data can be sent bidirectionally over the connection. UDP is User Datagram Protocol. It is an unreliable connectionless protocol which does not require setting up the connection. However, the data may be lost during the transmission without the sender's notice, and it is suitable for one-way communication. Let's look into a real-world example using this network diagram. Here is the setup. The laptop is installed with Telnet client software. The server is installed with Telnet server software, which is running and listening to incoming requests on port 23. User have already typed Telnet 172.20.0.2 and Telnet protocol have been triggered, which in turn issue requests to TCP protocol at transport layer. Here, what the TCP protocol at transport layer does, it segments all the data from Telnet application. It assigns a sequence number to each segment. It then transports all the segments to network layer for addressing. TCP will redeliver any missing or error segments notified by its peer. Let's analyze the packet captured by Wireshark. As you can see, at the application layer, Telnet protocol is being used. It attaches its own information as the header of the application software data. After that, TCP protocol is being used at transport layer, and it also attaches its own information as the header of the Telnet data to make it a segment. Let's look into the detailed information of TCP protocol. This is the sequence number of the segment. The source port is a random ephemeral port, and the destination port is 23, which tells us that this packet is from the Telnet client, which is to connect to the Telnet server. We'll talk more about TCP protocol in another video. Let's sum up our video with the keynotes. Transport layer responds to service requests from the application layer and issues service requests to the network layer. The data at transport layer is called segment. Transport layer defines protocols for setting up the level of transmission service for applications. Transport layer identifies the protocols in application layer by the port number. The two well-known protocols developed for the transport layer are TCP and UDP. TCP is a reliable two-way communication protocol. UDP is an unreliable one-way communication protocol. This is the end of this video. Thank you very much for watching.